No, I don't need that.
Should be good to go.
All set? Just, I guess we can't, I guess we can tell it's in the room too, right? Okay. Okay, welcome to our weather discussion for today. Professor Morgan's got a couple of pieces of news that have to do with former Typhoon Halong making landfall in western Alaska that we talked about last week during the discussion. So I'm not going to usurp any of that because he sent me this text message with one of the articles in it, and I couldn't get past the paywall, of course. Being cheap and a technical dinosaur at the same time is a bad combination. But anyway, there's some stuff to hear about that. You'll recall from last week, this is near the beginning. No, it's not quite yet. We'll go back to the beginning as it comes around. So this is a 1 week long animation over the Pacific Basin. So starting at about the time we met last week. And at that time we were talking about an event coming across the jet and into the Bering Sea and then making its impact known in this part of western Alaska, which at this time of year often has a substantial permafrost and maybe even a little bit of sea ice, but things have warmed up over the last several decades, so neither of them are quite as strongly available at this time of year as this anymore. So this storm came in, and you remember we had sea level pressure in the forecast going down below 950, some low 940s were in the forecast. And so very heavy winds, waves, and whatnot did a lot of damage to the western part of Alaska. And people lived there and were not able to evacuate. So there were lives lost as well. And so there's a story behind that weather story that we'll hear a little bit more about later today. And it's not savory. So looking at this whole week, there's a couple of features I'll draw your attention to as we come back to the beginning. First, for a very long time, there was a weaker cutoff earlier in the week, but what happens next with this big ridge over the Gulf of Alaska is the development of a cutoff right off the coast of California. Here it comes, California, Oregon. And it lasts for 2 or 3 days there, from Tuesday to about midday Thursday. Heavy snow in the Sierra for the first time of the year. And then look at the vortex structure remains for quite some time as it moves across the Intermountain West. Had something to do with our rain on Tuesday night into Wednesday morning. So a very long-lived disturbance affecting lots of our country, beginning as sort of a cutoff off the California coast. And it follows a sequence, and we won't investigate it in detail today, but it follows a sequence that I think becomes a little bit more common at this time of year. Big ridges develop over the western part of North America, occasionally within the northwesterly flow in those ridges, rather dramatic tropopause folds can develop, and they assist in the development of these cutoff low features at relatively low latitude. They'll make their way even further south by the end of the winter, all the way over to northern Mexico. Now they kind of stop about at mid-coast of California. But as you can see, that cloudiness right over the Sierra dropped, what was it, 8 or 9 inches of snow, I think somebody said in class the other day. So some of the first substantial snows of the year in the Sierra Nevada. And that's good if you like to eat vegetables, because a lot of the water that irrigates your crops here in the valley comes from that snow melt. So it's nice to start building it up as early as possible. Speaking of building snow mass, we're not having a really good start with that production in Western Canada. And even in South Central Canada, there's been sort of a lack of early season snow. I don't think there's anything alarming about that. It's just that I get excited if I see it coming in the early season. I think, oh, that sets the radiative stage for the development of cold air masses closer to us than would require long excursion from the high latitudes. So that threat is not yet in place, and so that probably means we can breathe easy. We're not going to see desperately cold temperatures in the late part of October. At least they won't be built proximate to our location. That's what it looks like right now. But you can see it's been a very, very active Pacific mid-latitude storm track for this whole week. So this will be the last time we'll go through the image. So you'll see one storm after another raking the Aleutian Islands, or sometimes just south of them. How long makes its way in here somewhere, I'm not exactly sure, right about now, I think. And so we'll see more about that later. But late in the week, you'll see there's a pretty decent storm right there going across the Aleutians, and that ends up with a massive cloud a patch with it, and then a second one here at the date line, and then there's a third one emerging right at the date line right now. And so there's a whole bunch of storms, a very active storm track now in the northern Pacific Basin for the first time all year, because we've been kind of decrying how boring the weather's been. in a variety of different forms. Friday afternoon is one of them. But notice again the ITCZ, at least in this longitude swath, not particularly robust in terms of the depth of the clouds. So that's interesting. That's been the case for a long time this fall. That's fairly interesting. So Pete, can we now go from this view to a more proximate view of just the continental U.S. and adjacent waters over the last 6 hours or so? See what's happening in the satellite there. So here's our fake color image, and you can see a fairly broad disturbance off the east coast of North America that has induced cold advection, which shows up in the stratocumulus right off the coast and bears the shape almost of the coastline, as it always does. And then a little bit more substantial clouds to the northeast and then even straight north of the disturbance. But it's a broad circulation maxima. There's a couple of different tropical disturbances that I don't see particularly here. One of them's Karen, maybe is off the page. And then, what's the J? Anybody know? Nikhil, what's the J storm? It's Jerry. Jerry is a fairly weak tropical disturbance that has been in the NHC webpage today. And then over us, and north of us, I should say, a fairly substantial cloud mass to our north, scattered clouds over the state itself right now. And that's generally the case over much of the higher latitudes of the western United States, crystal clear over the southern latitudes of the west, and not really any obvious disturbance that you can see immediately looming off the coast. We'll take a look at this west coast satellite image in just a minute. Okay. So let's first see, before we do that, let's take a look at the radar over the continental U.S. And so one sees maybe, I think I saw this yesterday in 452 as well, it looks as though there's kind of a ridge axis right over the central Great Lakes, southern Ontario. Elements, and I'm deducing that from elements of the precipitation shield, seem to be turning in a clockwise fashion over that ridge. And then there's not too much to describe over the western United States anywhere, actually, and not much in the east. So this little patch here over northeast Ontario is a little bit about the most impressive one. And maybe it's even a bit of a lake effect off the northern part of Lake Huron. So broadly speaking, not too much precipitation across the country and adjacent locations this afternoon. Let's take a look now, if we could, Pete, at the super Petes. We'll start at 300 millibars. Yeah, that's nice. So fairly wavy flow over North America. That's always interesting. This is the reflective of the broad circulation feature we saw in the satellite picture off the east coast of the United States. On the western side of this upper trough is a stronger jet. That means this feature is not likely to be moving out very fast. Ascent in the left exit region is likely to keep the air cool in the center of the storm, which makes it hard for the thing to move. So every time I see the jet on the western side, I get excited that it won't be migrating and may even be deepening a little bit over time. So there's our upper level trough off the east coast. Here's the ridge at 250, and presumably extends through deeper layer as well. We'll see in a minute, but that actually does testify to some of the anticyclonic motion of elements in the weak precipitation field that's over us. And incidentally, Lake Huron, right entrance region of a pretty strong jet, tends to be a little bit of a tendency for ascent in such a location, so that might be the thing that give it just a little bit more oomph. May also be a lake effect impact as well. We'll have to look at the temperatures there to assess that possibility. And then a broad trough over the western United States. Here's feature number one. It's kind of the residual of the cutoff that I talked about with respect to the satellite picture that was off the coast all week long. It's gradually gotten itself reabsorbed into the flow, and that's where it is now over North Dakota. But there's a trailing trough across the Four Corners states into Southern California and even arguably into northern Mexico that has been quite persistent, even in the face of the motion poleward of that cutoff. And then the most interesting thing to me is this intense jet, 155 knots, maybe even higher than that, 170 in the middle, right off the coast of British Columbia. Let's go to 300 millibars and see what it looks like there, because that's...
Oh, sorry, I thought that was 300.
Yeah. So, really intense winds, 135 knots or so just north of Vancouver Island, and yet Prince George is like 65. So there's extraordinary shear across central British Columbia right now. And you can see the same features exist at the slightly lower level of 300 millibars. So this is all polar jet, looks like, that we're looking at. Let's go to 500 Pete. And sometimes you get really interesting thermal structures. You sure do in this one. Minus 31 at Prince George, British Columbia. That's the coldest I've seen yet at that low latitude. So that's really cold air at 500 millibars for October, what, 17th? And it's the Battle of Saratoga. Happened twice during the Revolutionary War, 1777 and 1781. Isn't that weird? Same day, same place, British lost both times. So they were down 2-0 and they never recovered. Sounds like us. So here's the baroclinic zone at 500 millibars, which is very conspicuous. It's minus 13 at Quileute, minus 31 at Prince George, and most of that contrast is not between those two stations. It's kind of concentrated in one half of the distance. That's a strong upper front that's developed along with that strong jet that's coming across the coast. And you can see at least the thermal contrast there, but look at the shear. It's 115 knots at Nanaimo, 30 at 500 millibars at Prince George. That's incredible. 85 knots of horizontal shear there. Pretty remarkable. And there's a little bit of a cold pool associated with what was the cutoff several days earlier off the coast of California. It's maintained, at least thermally, a cutoff structure, and even with the winds. If we had a wind in the northern part of Lake Winnipeg, you'd probably see a little tendency to be heading from the southeast there. So really nice, long-lived cutoff disturbance. What's interesting to me is, and this is in the forecast, so I won't say too much more about it than this, but this is a developing upper-level frontal system. And then this trailing trough to the south and southwest of the cutoff develops its own little tight little vortex maximum over the next day or so. Those two features are separate. This one is really a robust little vorticity maximum about a day and a half from now. And meanwhile, this is becoming a strip of increasingly strong vorticity, and that's characteristic of upper fronts. They never quite merge, but they do have an interplay that leads to a fairly substantial weather system just to our east, it looks like in the forecast. It's going to rain heavily over Michigan, parts of southern Ontario, not so much here. But it's going to be a really decent fall event. Some of those places will see the leaves come off the trees because the winds will be strong. We may even get a little bit of strong wind here on Sunday, but nothing like what they'll get just to our east. But it's a conspiracy between two independent and continuing to develop features, which will be quite fun to watch. Okay, so now if we could go to, tropical tidbits. We can't pass a 150 knot jet without, first one of the year, without looking at the structure. So let's go to, the region here isn't so great. We have to go to North Pacific, and then let's get to 12Z on today. So we got to get another model run put up here. So let's try that one. And it always goes to 6, so I don't like that. I want to see 12Z. So can we look at the 0 hour, or we can't? Maybe we have to go to the prior run. That's okay. We'll go to the 6-hour forecast for this one so that it's right at the same time we saw our observations. Yeah, okay. And then if we can look at the jet on this, Pete. Yeah, that's perfect. So just a recreation of what we just saw on the west coast of North America. First, I'll point out something I couldn't show on the prior map, and that is that there's an active, even stronger jet features to our west. So this jet extends nearly continuously from north of the Korean Peninsula all the way to Seattle. So that's pretty unbelievable with only 2 waves in it. So a remarkable jet, and these purples are in the 140, 150-ish knot range of speed. Okay? And they have pretty decent waves. Each of those waves has a cyclone with it. This one here, south of the jet, turns into a beast a couple of days from now. So I'd like to look at a cross-section right across the central part of Vancouver Island, if it could be. And that's control, and you slide the mouse to do that. So let's start up here in northern Saskatchewan, or Alberta, sorry, and down to about there, yeah. So let's see what this looks like. Let's do the PV. Since it's a jet, I'd like to see what that looks like. Wow, that's pretty nice, isn't it? So we're cutting right through the core of the jet, just about perpendicular to the wind speeds. And you can see the isotachs are dashed 120 knots at roughly 300 millibars, clearly a polar jet. And then the PV is shaded with the 2 PVU isotel in black. Comes all the way down to, what is that, 700 millibars. So if you're at a high mountain station somewhere in coastal British Columbia, you may smell the whiff of ozone in the morning as you wake up, because it's not that far away. This is the stratosphere all the way down to about 700 millibars. The green lines are potential temperature isotopes. If you were drawing this by hand, you'd kink them a little more. This is a very sharp upper feature. The question is, how does it evolve? And that's a forecast question. So you'd like to know how that's going to evolve. But you put vortex substance in the middle troposphere, it tends to generally create some weather. And in fact, it does with this one, but not that dramatically in the forecast. A little bit of precipitation over parts of the Northwest. But it's a really beautiful structure and well worthy of our discussion. So coincidence of the horizontal temperature contrast in the theta lines with the vertical shear. And that has to be the case. Tyler, why?
Vertical wind?
The thermal wind, yeah. So I'm giving him a hard time all week about this. So that's a nice picture of that structure. And the dynamics that drive its development, we'll wait for one that's a little bit more proximate to us and maybe better developed. I looked at it at Vis 5D today. It's not so great after this time, so we won't say any more about it. Okay, but one of the other characteristics of upper fronts, like this one, is that they don't have much manifestation in the lower troposphere. Here's the PV tendril comes down, as I said, to about 700. So why don't we go back to the superpeats? Let's look at the 700 millibar map for the same time. Wow, there's a little bit of a temperature contrast. It's like -10 at NIMO and it's 0 at Quileute. So there's a little bit of a temperature contrast there, but it's not like it was at 500 millibars. And in fact, we see this disturbance upstream in the Gulf of Alaska along the Aleutian chain that we can kind of see in the satellite picture. And there's the manifestation of our historical cutoff. It looks more and more cut off in the lower troposphere as you get up there, but it's still got a cold pool in the middle. Let's go to 850. And at 850, there's absolutely no semblance at all of any baroclinicity in the same region where we saw really strong baroclinicity at 500 millibars. So these are not surface-based fronts. These are things that are totally different animals, and they have something to say about the development of sea level pressure disturbances, but not at every point in their life cycle, and certainly not at this one. So we don't have any substantial temperature contrast. Look, I'll take the same two stations. It's only now a 2-degree difference between Nanaimo and Quileute. It was 10 at 700, and it was more like 15 at 500. So the temperature contrast gets weaker and weaker the closer you get to the ground. And meanwhile, just south of Lake Winnipeg, here's where our cutoff is, and we are in a region of pretty strong warm advection. Green Bay's 14 degrees this morning at 7 a.m. At 850 millibars. So what should you add? Even in the most stably stratified atmosphere, you ought to add 9 degrees to that, so you're going to be maybe 70 degrees today, which is remarkable with clouds. We'll see if that actually turns out. And that's uniformly warm all the way down to the border with Mexico, and even in Mexico, temperatures aren't substantially higher, 17, 16, 18, Veracruz. So 14 degrees without too much warm advection, but a warm bubble that seems to sit right in line with this geopotential height trough. So interesting setup for us. There's a lee-side trough embedded in all this. There's a cutoff that's migrated to the border with Canada, and it's all coming together for some interesting weather in various parts of the Great Lakes states, with more to come. So I wanted to do one more thing. And we already did the Pacific because of going over there to look at stuff. Let's look at the surface map, Pete, just to get an idea of what these temperatures are looking like around the central U.S. Today. So, yeah, 71 already, and it's mostly cloudy. I mean, I know this was in the forecast, so it's well forecasted, but still, when you think about it, October now, we're 17 days into it. We're 7.3 degrees above normal for the month thus far. And this doesn't help, okay? I mean, we're not going to see a decrease in that trend of adding to the surplus because we're at 71 degrees. And you have to look pretty far away. You can't even find northwesterly winds until you're in southern Manitoba, where temperatures suddenly get into the 50s, high 40s and low 50s. So it's back behind here that this chillier air and drier air dew points are lower. We're at 58 dew point. But it's going to take some time for all that to make its way through here, given that the upper level disturbance is sequestered sort of over North Dakota and southern Manitoba. So we're going to enjoy a prolonged, I think, period of modest warm advection to the extent that the clouds appear and disappear during the day, we can see spikes in the temperature when the sun comes out. So we might see 75. It's already 71, and I don't think it's been sunny for very much of the day yet. And yet on the satellite, you can see there's quite a bit of breaks in that regionally. So we may see something more like what's going on in central Iowa, 73, pushing 75 later today, which I think is pretty remarkable for this late in the year. And you know, the latest 80 we've ever had was last year on October 29th. It doesn't appear we're going to do that again this year, but you know, it's not, you can see, it's not beyond the realm of possible, like unfortunately other things appear to be that are happening in Los Angeles. So that's what I have for today.
Do you want to show your?
Oh,
cold
850 cold pool. Tyler asked about that. So what about the hemisphere?
Oh, yeah.
And you know, I keep track of the 850 millibar cold pool, so if you haven't heard about this, I'll just tell you quickly what it is. I just measure the aerial extent at 850 millibars of air that's colder than -5. And it's easy to calculate in these fabulous reanalysis data sets that we have, or even the GFS analysis is what I use for the current record. And so here we are on the 16th, it goes through the 16th yesterday. This is the time series from September 1 to October 16th. And we're consistently below on every single day except maybe the first of both months, well, 2nd of October and 1st of September. Every other day in this now 46-day time series has been below the average, whether you calculate it for the entire long term, 1948 to 2014, or the 230-year climate features that are embedded within it. And we're the 9th warmest September 1st to October 16th out of the last 77 years or something like that. So we're in the top, you know, 15-ish% of all time. And it starts to get to the point, at this point in the season, where the actual warmest one is way, way ahead of us now. I mean, it doesn't mean we can't win between now and December 1, but it's unlikely that we win that.
Is that winning, John?
For me, it is. For me, it is. I want to see records, and I can constitute a data set any way I want so that I come out on top with my sort of measure. But yeah, you're right. It's a good question. Is it winning? I don't know. And it's the whole hemisphere. So, you know, we might be doing worse in North America than they are in Europe or vice versa. But it's the whole hemisphere. And we're halfway from September 1 now to December 1st. And I hate to remind you of that, but you can see it graphically. It is December 1st. We're halfway there. And we're 9th warmest. So we get a couple of hemispherically warm events. We may find ourselves back in the top 5 or so. We were last week from September 1 to October 2nd. It was the 4th warmest. But now we've kind of dropped off a little bit, even though we've consistently stayed below the average over this long term. So I'll give you an update on this every couple of weeks, which I guess means maybe there'll be just 3 more updates before we get into the winter time. Right now, I think the slope of this line is about as steep as it is any other time of the year, in the positive direction. It slows off a little bit here, and it certainly slows off from December 1 to January 1, even though we keep increasing the area. But the rate of increase is most rapid through the month of October, which is, you know, filled with fascination. We have all sorts of exciting things going on. As you saw, a rev up of the storm track in the Pacific. Professor Lang could tell us that the polar vortex is probably beginning to take shape. Maybe it already has. All of these things are somehow related to each other. It's pretty exciting stuff. Okay, any questions or comments? Tyler?
Would a warmer 850 level decrease the strength of the polar vortex?
It would change its latitude, because what we really see that's not on this diagram is where is the -5 isotherm. If it's got a smaller area than it has in the past, probably means it's been sequestered to higher latitude. And that means that the strongest thermal contrast is at higher latitude than normal, so that the circulation, the stirring that's actually going on as the polar vortex sets up, is smaller than it would be if it were at higher latitude, because the circulation times the area is divided by the area is the vorticity. But the vorticity times the area is the circulation. And so bigger area means bigger stirring. And I think that this thing testifies to a systematic reduction in the amount of stirring that goes on in the troposphere, and then probably also if a similar measure exists in the stratosphere, you can see the same thing.
John, a related question.
Yeah.
Do you keep track of kind of this, to the extent that the 850 cold pool is a contiguous entity in the northern hemisphere, the largest part of it, of the center mass of it?
No,
Located and
no.
how that
I don't. That's interesting. You could certainly do that. It wouldn't be that much more work to do that. I don't. One thing that I have not systematically also kept track of, but it's available immediately, is measuring the zonally average distance between the -5 and the -15 isotherm at 850. Because I keep track of all those areas. Each one of them I can assign what's called an equivalent latitude, which is almost the zonally average latitude of the isentrope itself. So just measuring that distance tells you about the variability and the thermal wind. So you can see where that center of mass is much more easily than the center of mass of the whole block. But you could do that. Yeah, you could do that. I have not done that. That would be interesting. Any other questions or comments? Okay, let me get rid of this way.
Thanks, John. So what I first want to do is just very briefly, this was something that's sort of hot off the press or hot off the Associated Press in terms of my looking it up, was about the remnants of Typhoon Halong and its track into parts of western Alaska. So we'll go to the website. There are a couple of them. We could just even take the latest one right here. What was interesting about this was, unfortunately, the number of, I guess, houses destroyed, over hundreds of houses, over 100 houses destroyed. A lot of people having to be airlifted out of the area. I think 1,500. It's considered one of the largest airlifts in Alaskan history because of the storm. And then, the thing that really interested, quick perusal of a few articles, but I could send you the links or ask Pete to send links out if people are interested. There's a Weather Service, we'll look at a brief period of a Weather Service briefing on the storm that occurred on, I think it was Sunday morning, early. But what they're attributing the issues with this storm in terms of the folks having to evacuate was sort of lack of notice or people being prepared for this. Last Weather Watch, if you recall, John did an excellent discussion of the evolution of the storm, where it was generally going to track and the potential impacts of it. And so that's something you would think would have been well communicated. And I'm not at all blaming Weather Service. We don't know what the issues are yet. But there have been some articles about East WF having issues with the forecast models. I have not looked at any of those things. But one of the things that does begin to appear in some of the articles is that I guess the Weather Service had a sense that the cyclone was going to track more to the east of Nome in Alaska, and it actually tracked, more to the west of Nome, or right over Nome, because that was kind of a historical track for storms during this season or during this time of year. In fact, the track was much further to the east, and that caused more problems for some of the bays, significant storm surge, record-breaking storm surge, and flooding associated with that. If we just scroll down here just a little bit, this is, again, we can see the sense of hundreds of folks, most significant airlifts in Alaska history. That's just really remarkable. The water levels rising more than 6 feet, structures floating out to sea. Again, just pretty horrific. And communities hit hard. And one of the big issues now is we've lost over, 45 minutes of daylight in the evenings. Things are getting dark, things are getting cold, winter's about to set up. People recovering from a disaster like this at this time of year is going to be problematic, right? It may take them a full year before they actually get back maybe into some of their homes and things like that. But certainly over the winter, you have a lot of people that are now without houses, which is just really unfortunate. We scroll down a little bit further, just really seeing some of the statistics from this. Again, challenges with evacuation as this was occurring. And I don't know what FEMA's doing. I don't think anyone knows what FEMA's doing, unfortunately. That's just, that's another issue beyond that. And then also, what federal services are going to be provided when you have a government that's shut down. That's another whole issue there. So let's go to that second link, please, Pete. Again, just a discussion of this from an NPR station. See some of the flooding, houses overturned and things of that sort. And we see with any significant storm with wind. And if you scroll a little bit further down, I think there's a Weather Service link, and we may be able to that's a little bit further down. Oh, keep going, please. That's actually, this video right here. Click on this. And also, at the end of the video, we're not going to follow through this. So, the Weather Service over the last several years has been deploying folks into emergency management offices across the state. So this is one of the emergency management offices in western Alaska. They have a Weather Service forecast officer not at the office, but he travels with his laptop and his communications information to the emergency management site so that they can be in direct contact with emergency management officials in the area. And so he's giving a briefing to the residents in that area, but also, probably then coordinating that message with folks that are in the room that he's located in. But if we could just kind of go through toward near the end of this, maybe roughly about here, a little bit further down. Just looking at some quickly, let's let it play from here and maybe put the volume up a little bit. Just talks about some of the records that have been.
6.6 feet above the normal highest tide line. The previous record was 4.7 feet, so this is almost 2 feet higher than the previous record that we had seen. Quigillinock, it was up to 6.3 feet above the normal highest tide line, and that beats both of the previous higher ones that we've seen in recent history for Quig at August 18th in 2024, got up to 2.5 feet, and Murbach was only up to 1.7 feet. That is almost 4 feet higher than what we saw during either of those bigger events in recent memory. We also had some very strong winds, some of the
So here's
observed
some
winds that we
of
saw
the
from
wind
Cornwall
reports that
Islands
they had, at
and
least
West
initially.
Coast.
This was a significant.
Kusildak got up to 107 miles
All of
per
these,
hour.
except I guess the last
Tooksuk Bay
one,
up to 100
strong
miles per
hurricane
hour. St.
force.
George 98. Reindeer River up to 86. Chinook 84 miles per hour. St. Paul
We don't need to go through
81.
each of those, and we
Kotlik,
could maybe just go a little bit
78.
further ahead
St.
to the
Marion,
next slide, I think.
76. Chivac 74.
Maybe it.
And part of this is showing the huge difference in land areas that we
That's-
had.
yeah.
Exceptionally strong winds getting up
So this
to
is,
hurricane
yeah,
level
we can just fade
for
that
those
out.
wind gusts for all of the.
Really, a big storm. The impacts, again, reading some of the articles really quickly, was a suggestion that the Weather Service had a sense that the storm was going to track further to the west. It didn't, and I don't know. We could look at the model runs from late last week into the early part of the weekend before the storm made landfall, but there was something odd about how this unfolded. Post-storm, this was Monday or Tuesday, there were reports that I think every single radiosonde location in the state was out because of some of the damage that had occurred for this particular. And now we could look at the super peats to see just how bad those were today. I think they're probably now beginning to report, but there was an outage for both weather stations and some of the sounding stations in the western part of the state. If we just get that. So today, this is okay. If we went back to Monday, if it's possible. Yeah. I haven't looked at this for verification, but there's at least one map that showed it kind of blank.
It's totally blank. The whole state?
Yeah, go back, yeah, if you go back to the very beginning of this.
The size of the United States has one sounding. That's the sound of Alaska.
So somewhere out here, look at that, just only 1, 2 on this, and that's on Monday morning. I don't know if we got the 0Z on Monday, if that was available.
That's a bad place to have no ops, because you've got a 160 knot jet racing
Right,
across the
yeah,
southern.
so he lost some there during that time period. So really a pretty big storm impacts on the observing system, which then has downstream impacts on predictions and forecasts for our area. And so, again, it might be an interesting case. I don't know if it's 452 worthy for someone to pick up and look at, but I don't know. You got anything to say about that, John?
Well, we were looking at Umberto for our mini case study. And this was exactly like it in a couple of characteristics, but more intense and more of a serious threat to our own country. So, yeah, I mean, it's a great case.
For a student, yeah, that wants to,
Great.
for their project. Okay, let's get out of this. We'll go to Kai. For our weather here, it's going to be a bit much more tranquil this weekend. Because we have a game tomorrow with Michigan, and then also there are some activities both at the Capitol, west side of Madison, regarding, public concern about what's happening in our federal government. Let's first go to the time height first. I'm going to, sorry, John, no meteorogram. One, because it's still embarrassingly messed up with the dew point, but we'll still show it, but show this first. And what we see here in the time height section, again, yellow is the potential temperature. Finally, we get a dynamical tropopause that gets down to below 600 hectopascals this year. So we have a really deep upper trough that's going to pass by us, but that's on Sunday. Before we get to that, we see in relative humidity, it's red, blue of vertical motions, meters per second. We see this strong south-southwesterly flow that persists until this evening. Then winds become a bit more westerly as opposed to southerly. Before that occurs, sometime right after 0Z on Saturday, so this evening, after 7 p.m., we see this big burst of vertical motion. The column gets nearly saturated, and so we have at least one rain event here. Things kind of stay, with winds that backed a little bit, they're more westerly. Yet another surge of significant rain expected here by the time we get into late Sunday night, early Sunday morning. So two big pulses of rain, and it's really interesting. I'd like to go to your page. I tried to find, I don't know if there are two Omega pages, like a new one.
Yeah, there's one that you have to put new omega.html.
Okay, we'll go to that in a second. Well, not just yet. But one of the things I think is kind of interesting about this event, the second event, is we're getting this significant period of rain with southwesterly flow, even northerly flow over us during that time period. But at least in this model depiction, we get, you'll see, almost a half inch of rain during that. And so it's not an obvious situation, but some of it's certainly frontogenetic, I think. But I wanted to sort of uncover that a little bit by looking at those diagnostics.
Yeah, the 1906 vertical time series, vertical profile shows really strong backing of the winds with height.
Right, you can see that.
The ascent and the cooling down. That's the cold front passage.
Right. Yeah, so this is going to be a fairly dramatic cold frontal passage, but in this westerly flow, you think this is the front. No, we actually have two frontal passages, a more significant one. This might even be more just of a trough passage, but this is going to be a significant cold frontal passage. The other thing that's really interesting is you can see these isotropes getting steeper and steeper. That's due to the significant ascent that's occurring as we move forward in time with this, as the upper trough begins to approach. So this is going to become, and this ushers in really a more fall-like feeling weather when we get into early next week. But then after that, we could be back into the 70s by this time next week, unfortunately. So, sorry, John, it's just not going to stick yet. Let's go to the meteorogram, please.
I thought Tuesday we're going to have temperature at 850 about -4 with precipitation. I don't know if we won't see a snowflake today.
Right, that's possible, but after that, looks like we begin to warm up. So here are the two big surges of rain. Red is the sort of instantaneous precipitation rate, and then green is the total accumulated amount. And I will say we'll look at a couple different models. This is one that's wetter than many of the other ones, but there's the first rain event after 0Z, some light rain, and then we get the big surge just around midnight or so. And then tomorrow we get another surge of rain, getting us up to almost an inch total over this time period. So during the day tomorrow it'll be dry, but it's going to be late tonight, and then again tomorrow on night that we're going to get these surges of rain. For temperatures, looks like we get into the middle to upper 70s perhaps today. Maybe again tomorrow if we get some if the clouds sort of break up briefly enough, but then kind of the bottom drops out when we get the first surge of cold air that comes in as the upper trough passes by, and winds shift dramatically more to the north and are really going to be gusty. So and dew points, still don't know what's going on there, but temperatures dropping significantly on Sunday relative to today and to tomorrow. Let's go look at the surface map, please. And actually, we'll look at the surface in terms of first of all, just close in, and then we'll look at the bigger picture. Let's go to 6 hours out, which is kind of around now. We saw this on the radar. Light areas of precipitation that are showing up on the radar even now, just in the western part of our state. This doesn't really depict those just yet. If we go to 3 hours ahead, maybe I'm just going to bring the loop up and then we can stop. We'll stop that. Let's go to 9 hours. And we begin to see, let me just check the time. This is at 12 hours out. We can go back a click. So it's every 6 hours, okay. So 6 hours later, so this is gonna be this evening. You can see, you can move advance one, please, Pete. We see this huge area of precipitation that sets up. We're still in that southerly flow. Again, this is at 0Z this evening, so we're still dry, but we can see rain is just to our west. And you have a very subtle wind shift in this. Some of this could be convective, and the downdraft's bringing down winds that are in a slightly different direction. But this is, sort of a confluent flow. There is a modest frontogenesis associated with this band of precipitation as it comes through. Let's go ahead another 6 hours. It makes it through Madison, still making it through Madison by just right after midnight, 1 o'clock tomorrow morning, and and then we go ahead again. You can see the temperatures don't dramatically fall off. Temperature advection, in fact, is pretty close to neutral. I'm not going to look at the little wiggles in that. If you average everything out, it's fairly neutral, so it's not a significant burst of cold air behind this trough line that goes by us. In fact, the winds you lose any sense of any confluence along that boundary, as well as the temperature gradient at this time. So let's go ahead further into tomorrow afternoon. We'll stop there. This is again 0Z tomorrow night. We've sort of jumped through tomorrow, and you get temperatures. This is at the surface around 18. This is the 2-meter temperature, but we saw in the meteorogram it gets a little bit warmer than that. But the most significant thing that shows up is this really strong confluent flow with a temperature gradient. Strong northwest winds here, and the winds becoming more southerly, so we get that setting up with precipitation. The back here, where the precipitation has already fallen, this is the accumulated precipitation, just sort of almost straight northwesterly flow. Let's go ahead another click. This is the rain coming in, and I mean there is some slight changing in the wind direction through here, but it's not, to me, obviously frontogenetic. Down here, that's clearly frontogenetic. You can see the strong southwest winds, confluent flow right here along this band. But further to the north, just a broad area of precipitation that doesn't seem to be necessarily driven by frontogenesis. I don't know, John, what your take on that
There is
is.
differential temperature advection, but it's only at the surface. I don't know what to make of that, but
Right.
Often, as you're thinking probably, you can have strong frontal processes to the south of where the cyclone itself is maybe developing.
Right.
And that provides, and different forcing provides the ascent for the precipitation there.
Right, so we could look at this same time, which is 42 hours in, at 8:50, I believe, if those came out. Let's just go directly to that map. No, 8:50 at the, sort of zoomed in. And I guess here, this is more evidently frontogenetic,
Yeah.
right along the boundary. That really shows up nicely here. That's one thing I hadn't looked at. I've been looking at the surface so much. That's a reminder, just don't focus on surface frontogenesis. You want to look in the mid-troposphere, and that shows up pretty well
Yeah.
along the boundary. Thanks, John, for that. Okay, let's step back and look at the bigger picture. We'll go to the 12 hours into the forecast, 6-hour precipitation. Yeah, that's it. So here's that band of precipitation with the precipitation that's going to come in this evening. You can see cyclone associated with it is up in, just entering central Ontario at this point, and not really a front, but a trough that extends to the south of it, beginning to progress toward us. And then with that cutoff that we saw earlier, we can see sort of, or actually with the jet that was entering western U.S., some precipitation in the western parts of Montana and Idaho.
Because this thing north of us is still that cutoff.
Yeah, that's the cutoff.
California.
Right.
Isn't that amazing? And look at it, it's turning into a big precipitation producer again.
Yeah, so really nice structure with that. And then we go ahead 12 hours, please, Pete, into tomorrow morning. That precipitation has now just made it just about clearing our area. And you can see, again, flow field is relatively flat, not much in the way of really strong winds, or geostrophic winds, at least at this time during the day, during tomorrow morning. And this weather system is beginning to get perhaps a bit more organized, and we'll look at it from a couple different perspectives in just a moment. Let's go ahead another 6 hours, please, Pete. So 30 hours, noon. This continues to progress to the south and west, or south and east, and then we have this expanding area of precipitation that's over North and South Dakota at this point. Let's go back and look, let's go up to 500 hectopascal at 30 hours. We'll look at animation in a second. But this is the trough that we could see just hints of in the time height section and the first passage of this trough. The one that was in the southwestern United States begins to get a little bit more, I guess, interesting in terms of its structure. But the really big thing is the evolution of this sort of slug of vorticity as it really begins to amplify, moving into out of Wyoming into parts of Colorado, Nebraska, and South Dakota at this point. We can go back and look at thicknesses, but nice advection of vorticity. We want to see if it's a geostrophic advection of vorticity or by the thermal wind downstream of it. That could be the reason we're seeing this blossoming area of precipitation in those areas that we were just looking at. All right, let's step ahead another 12 hours. Let's go to 42 hours, please. At the surface. So, weak cyclone has begun to develop over parts of southern Illinois. We're kind of caught in this region between this, areas of precipitation that's what already passed by us, and this sort of developing area of precipitation just to our west. This is by, again, this is at 42 hours in the forecast. We saw frontogenesis was occurring in the middle troposphere, and that's all downstream of this upper trough. But if you were to look at, sort of try to diagnose this by advection of vorticity by the thermal wind, we could look at that. We'll see the vorticity is pretty much aligned along these lines of, along the thickness contour, so you're not going to get much in the way of significant advection. Let's look at that, again, just to go back to 500 millibar vorticity at 42 hours.
Yeah, you get
So-
a big slug in western Missouri.
Yeah, you're not going to really get it. But down here, just to the east of this, or to the west of the trough axis, you can see, east of the trough axis is where you can see there is some significant advections, and that helps to support the developing cyclone just to our south. So if this were wintertime, John, and it was cold enough,
Whoa, man.
you'd be on the edge of your seat, but probably thinking this is not going to be the one for the
You know, the one
season.
thing I wouldn't like about this
What's
is
that?
that the flow is perfectly straight from the Mississippi River all the way to northern Canada. There's no downstream ridge. And all the
Right.
precipitation, and you can even see it kind of in the vorticity field, speckled like it looks like,
Mhm.
it's a squall line. So there's gonna be very local regions of strong forcing percent, but it's not gonna evolve into anything big.
Right, and I think the close proximity of that first vortex strip that went by, if you're looking at vorticity advections, even if you had a little bit of it, there's going to be a lot of sort of cancellation downstream of this as well, so this is not going to be a very organized.
No, and the only place
Working
where
motion
it's
field.
substantial is right, at this time, right over St. Louis. And
Right.
that was a region of pretty intense precipitation, maybe some surface development, but the whole structure downstream of there is not favorable for continued development, unfortunately.
Okay, let's go ahead another 6 hours at 500 millibars, please. 48, yeah, that works. 54. And then this just ultimately begins to sort of just wrap up. The vortex strip that was out ahead of it is now kind of losing its own identity, and we have this large mass of vorticity now all to our southeast at this point. But by this time, most of the precipitation for us is over. And a ridge is yet to build in, at least briefly, and then yet another weather system from the Pacific and the Pacific Northwest. Let's look at the surface map at 60 hours, please. And so, as John was saying, really nice rain event for parts of Michigan at this point, and fairly decent cyclone that's moving into Canada at this point, kind of strung out ahead of that upper trough and closer to that slug of vorticity. And by Sunday evening, we're getting at least a surface ridge beginning to develop over us. So light winds Sunday evening, that could be a chilly night before we see the warm advection starting up on Monday. And then the next question is what happens with this next weather system as it moves over us. So let's go to pivotal, and a couple things I want to look at just for comparison, please, Pete, will be, let's get that set up for this week. For the time, yeah. And let's go to 48 hours. That's around the time the precip is over. And then I just want to do a comparison of model forecast. So let's click on this single image and compare models. This loop right here, click on that. And so this will give us, well, they've increased the number of models that are available to look at. If we sort of move across these panels, you can see various forecasts, all valid, as you can see, for 12 on Sunday from different models. There's the GFS. This is the HRDPS, I think that's a Canadian model, the HER, which is a short-term prediction model. As you go through this, you can see various solutions, if you will, for the cyclone, but also where the precipitation is going to be during this time. And that's a much different forecast the NSL MPAS run. The NAM, if we go back to that, one of the US models right here, has a much more, has a much broader precipitation shield just to our east at this point. whereas the NAM 3 kilometer probably shows the same thing, but it's a little lighter, and the cyclone's a little bit slower. There, let's go to the wrap. So you can see the evolution of this cyclone kind of different in these models. RRFS is one of the regional rapid refresh systems that may be phased out, even though it was just introduced a year ago. And then the UK Met, finally, that model. Again, so all of them have roughly a cyclone that's in the low 990s or upper 980s with a precipitation shield just through Milwaukee or over Milwaukee at that point, but at different levels of intensity for the precipitation. So that's a useful tool if you're just trying to compare some of the model solutions for a particular event. You don't want to take just one single model and then five, or WRF, or NAM, or GFS, but want to look at a collection of those. But we will go back to the GFS just to focus on a single one so we can look at the forecast as we go. You can click on GFS, yep. And then we'll go to 72 hours. And then very quickly step forward. That weather system that moved in from the Pacific Northwest by earlier on Sunday is now over western Minnesota. And if we step forward through this, we get this brief warm-up on Monday with warm advection, and then by Tuesday morning, the front has already cleared us, and we're back into cold advection. I think this is what John was referring to. We have a scenario where we have some light precip, 540 lines to our south. Air temperatures, if we go to the 2 meter above ground level air temperatures, we can click on this for Madison. That's still kind of warm. And if we just step forward on this a couple clicks, 102 hours, temperatures struggle to really advance much on Tuesday. So it'll still be a chilly day. And let's actually do a sounding at 105 hours, please. A little bit further north, I think, is where Madison is, but this will work. And you can see good part of the column until you get to about 975 millibars is below freezing. And it's moist, but I just don't think, it's not gonna happen, John, I don't think.
It's not.
I think this is gonna be kind of dismal, cold, breezy, fall-like, but not snowy.
Too moist. If it were 45 degrees with a dew point depression of 10, and a stray cloud came by dropping precipitation, maybe you can see a flake. That's not gonna happen.
Yeah, I doubt it. Well, we have a dew point depression of 9, so
Yeah.
what's a degree?
But the wet bulb, the ice bulb is not
Mhm.
freezing, so forget it.
That's fair, that's a good point. Let's get out of that. I guess we could stay there and just advance forward. Go back to the surface map, please, Pete. But the big thing is, you get chilly, and then just watch what happens. We'll go to 144 hours. So we keep moving this quickly. Cold air now is up to our northeast, and we have another weather system developing to our south. Let's go ahead. 168 hours, so this is next weather watch. Big ridge beginning to develop and warmth, but it's not super warm. You'll see, interestingly here, if you look at the temperatures, you say, well, this is nice high thicknesses. This time of year, with any sort of cloud cover precipitation, can really put a damper on temperatures. Let's look at that.
Oh, yeah.
And in fact, you can sort of see where it's warmer here. That's interesting. That's even more bizarre. But here's the cooler temperatures to the north where the cloud shield is. And we're not super warm.
That's a nice fall day
44,
right there.
yeah. And then let's go ahead to 216 and then we'll get out of this.
Oh, yeah, that's
So.
nice.
And look back at the surface map for a sec. I know we're running. Wait. So broad ridge, but now it's, or at least our temperature's been kicked back a few degrees cooler. And if we just go ahead to 288 and then finally 384. I like to look at the future in this way, but it's not much. We're going to get colder again, and then 384 finally. So we just don't stay warm. And the jet's going to still be, we do have a cutoff, or we have a trough here, but it's not going to be particularly exciting at this point.
Doesn't bode well for snow in western Canada.
No, it doesn't. I mean, if there were snow there, you'd have thicknesses in the 510s.
Yeah, let's look at the snow cover. Let's go to the bottom of this. Winter weather. John, you may not want to look.
I'm gonna have to look.
Snow depth.
Is that, oh, that's a change.
That's
That's a change.
sorry. Starting with 0. Look at that.
There is some.
That's high terrain. That's not the plains.
Right.
You need it in the plains. Well, there's a little bit in Saskatchewan.
So, and if we compare that, I guess that change might be over the entire, let's go to the beginning of the cycle.
0.
Yeah.
Yeah.
So we're going from nothing to something.
Something's coming down. It's about time. It's on schedule, but it's not enough, for me.
Okay. Are you greedy or are you just want?
Yes. I am.
Okay, he admits it.
I am.
All right. Well, again, the big things are, those links, if you're interested in seeing them, I can send them out to folks if you want to see the things about how long, but just the forecast issues with that, that's really interesting. And again, the devastation there is unfortunate. But for our weekend, it looks like no devastation, but it's going to be rainy this evening to around midnight or so, or after midnight in particular. And then again tomorrow evening, and then getting colder on Sunday into Monday. And then we warm up briefly on Monday. Tuesday gets chilly again, but then a slow moderation in temperatures during the week. So enjoy the weekend. Thank you, John. Thank you, Pete. Thank you all for being here.
Thank you, Michael. Thanks, Pete.
All right, I'm going to take this up.